Everything you have ever seen, every star, every galaxy, every atom in your body is 5% of what the universe actually contains. The other 95% is something we cannot see, cannot touch, and cannot directly detect in any way. We've given it names: dark matter, dark energy. But naming something is not the same as understanding it. And the honest truth is this: we do not know what the overwhelming majority of the universe is made of. Not approximately, not roughly. We are missing 95% of everything, and the only reason we know it's there at all is because of the shadow it casts on the things we can see. To understand what we're missing, it helps to first understand what we know we have. The universe contains ordinary matter, the stuff made of atoms, protons, neutrons, electrons, everything you can see, measure, or interact with. Every star burning in every galaxy, every planet orbiting every star, every ocean, every mountain, every living thing that has ever existed anywhere. All of that, everything, accounts for approximately 5% of the universe's total content. The remaining 95% breaks down like this. Roughly 27% is something called dark matter, and roughly 68% is something called dark energy. Together, they constitute nearly everything that exists. And our understanding of both of them is, at best, a description of what they do, with no explanation of what they actually are. Think about that proportion for a moment. If the universe were a book, ordinary matter, everything science has ever studied, everything physics has ever explained, would be 3 pages. The remaining 95% would be blank, not unwritten. Blank. Pages that exist, that have weight, that affect the structure of the book, but that contain nothing we can read. The first person to seriously propose that there was missing mass in the universe was a Swiss astronomer named Fritz Zwicky. The year was 1933. Zwicky was studying a cluster of galaxies, a group of hundreds of galaxies bound together by gravity. He measured how fast the individual galaxies were moving within the cluster, and he found something that made no sense. The galaxies were moving far too fast. According to the laws of gravity and the amount of visible matter in the cluster, they should have been moving much slower, or better yet, they should have flown apart entirely. The cluster shouldn't exist, and yet there it was, held together by something. Zwicky calculated that there had to be roughly 400 times more mass in the cluster than what he could see. He called it dunkle Materie, dark matter. The scientific community largely ignored him for 4 decades. In the 1970s, astronomer Vera Rubin confirmed the same phenomenon in individual galaxies. Stars at the outer edges of spiral galaxies were orbiting at the same speed as stars near the center, which is physically impossible unless there is a vast halo of invisible mass surrounding every galaxy, providing additional gravitational pull. Her work was impossible to dismiss. The evidence was everywhere. Dark matter was real. Here is the strange position science finds itself in with dark matter. We have overwhelming evidence that it exists. Galaxy rotation curves, gravitational lensing, the way dark matter bends light from distant objects, creating distortions we can map precisely. The large-scale structure of the universe, the way galaxies cluster and form filaments across cosmic scales, matches perfectly with the presence of dark matter and matches nothing without it. And yet, in decades of searching, we have never directly detected a single dark matter particle, not one. Every experiment designed to catch it has come back empty. It does not emit light. It does not absorb light. It does not interact with ordinary matter in any way we have been able to measure, except through gravity. It is the most well-evidenced thing in the universe that we have never seen, touched, or detected directly. We know it's there the way you know someone walked through a room after they've left, not because you saw them, but because of what moved. Dark matter, strange as it is, at least behaves like matter. It has mass. It gravitates. It pulls things together. Dark energy is something else entirely. In 1998, two independent teams of astronomers were studying distant supernovae, exploding stars, to measure how fast the universe was expanding. Everyone expected the expansion to be slowing down. Gravity pulls matter together. The universe should be decelerating. Instead, both teams found the same result. The universe was not slowing down. It was speeding up. The expansion of the universe is accelerating. Something is pushing everything outward, not just overcoming gravity, but winning against it decisively, and doing so across the entire observable universe simultaneously. That something is dark energy. It constitutes 68% of everything that exists. It appears to be a property of space itself, meaning that as the universe expands and more space is created, more dark energy appears. The more it expands, the faster it expands. The discovery was so unexpected, so difficult to explain, that the scientists who confirmed it won the Nobel Prize in Physics in 2011, not for solving the mystery, for discovering it existed. So here is where we actually stand. Physics, the most precise and successful science humanity has ever built, has spent centuries developing tools to understand the universe. We can predict the behavior of particles to 11 decimal places. We have mapped the cosmic microwave background radiation left over from the Big Bang. We have detected gravitational waves from colliding black holes a billion light-years away. And with all of that, with the most sophisticated instruments and mathematical frameworks ever constructed, we can fully account for 5% of what exists. The rest is darkness, literal physical darkness that we have mapped by its effects, named for its absence, and failed to detect directly despite decades of trying. But here is what I think is the most important thing to sit with. It's not just that we haven't found dark matter or dark energy yet. It's that we don't know if our current concepts of matter and energy are even the right framework for understanding what they are. The history of physics is full of moments where the answer to a mystery turned out to require not just new data, but entirely new ways of thinking. Newton gave us gravity. Einstein told us gravity wasn't a force. It was the curvature of space-time. The answer required a different question. Dark matter and dark energy might require something similar. Not better instruments, a better framework, one we haven't built yet, one we may not have the concepts to even imagine. There's something quietly extraordinary about the position science finds itself in right now. We live in an age where we can sequence the human genome, land a rover on Mars, and detect ripples in space-time caused by events a billion years ago. And simultaneously, we have no idea what 95% of the universe is. Both of those things are true at the same time: the precision and the ignorance, the achievement and the mystery. They coexist without contradiction. What we call the universe, the thing we study, map, and theorize about, is the small illuminated region at the edge of an enormous darkness. We are not at the center of understanding. We are at the very beginning of it. The 5% we can see is not a summary of reality. It's the only light we have to see by. The universe has not shortage of things that will break your mind, and as it continues to expand, so are we. See you next time